All right, everybody. This is the last lecture I got to do hiding behind a web camera. So I'm going to do everything I can to make this a doozy. Um, Before I tear into that, in this same module that you folks are working out of right now, there is a PowerPoint there called some terms and definitions that you should know. I'm going to ask you folks if you'd just take a look at that now. It'll probably take you a total of 10 minutes to pick your way through it. There is a pile of information, none of it all that tough to wrap your head around, but there's a pile of information that we're going to use for the rest of the class in that presentation. I think it'd probably be helpful that when I go through it, as far as lecture goes, if you folks would have just at least looked at it and read through it. Maybe some of it kind of rings true as you go through it. So if you do me that favor, I would appreciate it. Otherwise, please be aware that probably, so Monday I'm going to finish up on silage, and then probably Tuesday and Thursday I'm going to go through that one lecture I was telling you about, terms and definitions. And then let's probably plan on having an exam next Friday or a week from today. So, all right, I'm going to get going on this one. So today we're talking about hay. We're going to talk a little, it's going to be mostly about making hay. And the reason I'm going through that is I want you folks to understand what's going to make good hay, or if we're going to use the definition of good hay, something that has a whole lot of soluble sugar and protein in it, that we can get some good nutrition in our livestock, what are the things that have to be done to make good hay? So first of all, a definition of what hay is. I'm pretty sure you could all get there, but putting some sideboards around it. Preparation of hay is means which we're gonna harvest a forage during periods of time that we're growing lots and lots of it, and save it for sometime when we're not growing lots of it. So today's a perfect example. I'm kicking hay off the back of a pickup. The next thing I need you to know about hay is, if we had the power of absolute choice between go kick the cattle or the sheep or the goats out on a given field and let them graze it, versus if we go out and hay it and feed it to them at a different time, or shoot, even at the same time, the cost of those nutrients is going to be way more expensive by haying it than we would if we just grazed it. So I really want to put in your head that hay is expensive. And I also want to put in your head that hay is not going to be our go-to if we really want to drive performance. Works pretty good as a supplement. Doesn't work so good if we're asking something to grow or milk or finish or lay down fat, excuse me. So there you go. All right. So the intent of hay making is to harvest the forage at maximum usable nutrient per unit of land. So I want as much sugar as I can get, or as much energy as I can get per acre off of that hayfield. You as the manager have plenty of control over how much usable nutrient you're going to actually get put in a bale and be able to use. So that forage has to be dried. Feed books are going to call that cured quite a bit. Drying it out and curing it, same difference. We got to reduce the moisture content down to 15%. The book says 18% is okay. I'm going to tell you probably ought to start not sleeping very good at night if you're at 18% moisture in a pile of hay, particularly alfalfa. You can get away with a little bit more with grass. The moisture content at the time of swathing it or going out there with a swather, probably going to be 60 to 75% water. There's a lot of water that we need to get rid of out of that plant, but here's the trick. I just want to get rid of the water. I don't want to get rid of anything else. So we've got a long ways to go. So if we don't get that forage dried out enough when we're getting it put in a bale, the nutritive losses are going to be absolutely huge. And this next picture is also going to tell you why you don't want to mess around with getting hay dried down enough before you poke it in a bale. If you don't, here's the results. There you go. So everybody's gone out and rolled over a bale of hay that you're feeding horses or whatever, and that bale feels really, really warm, or sometimes it even feels hot. What that is there are microbes and yeast cells just floating around in the environment. They're always there. And if you give them a little bit of soluble sugar and give them some water, and then you do a little bit of work to exclude oxygen, i.e. stuff it in a bale and packing it up as much as you can, and then put it in a big stack to exclude oxygen, those microbes start digesting what is there. And one of the byproducts of them digesting stuff, just like inside of a rumen, heat is one of the byproducts. We can actually build up enough heat, you light a stack of hay on fire. I would say that definitely qualifies as a nutritive loss right there, a haystack on fire. So, also, by the way, because I'm the safety instructor, the one and only thing you do if you have a haystack on fire is go find a shade tree and watch it go. I've had a friend that actually died trying to knock a stack over and get a fire stopped in a stack. So if it happens, just hope you got insurance on it and let it go. So, all right, getting back on track here. So some of the factors influencing hay quality, just because we made the decision to go make hay and actually getting it done, we're going to suffer some losses in how much nutrition we can actually deliver down the road. And this is going to happen no matter how good a hay equipment you've got or how Johnny on the spot with your timing you were on this. So the biggest things that are going to affect the quality of the hay that you're putting up, always, number one is going to be the maturity of the stand. If you start with rank, over mature forage, whatever it may be, that's exactly what you're going to wind up with. We talked about the chemical and the nutritive value of forages last lecture, and yeah, basically that can be summed up as don't let it get too mature if you want good hay. So some of the things that surround actually haying are the length of curing time. So how fast can we get it dried down? That's going to be a huge deal. How much moisture was there? The hay people in the room are going to tell you, well, it depends upon if this was moisture because of moisture that came in with the air. So it's kind of moisture on the outside of the plant versus stem moisture. Stem moisture gets you in trouble. The moisture, if you had, a heavy dew one morning, that water isn't going to get you in nearly as much trouble as that stem moisture will. Certainly, how you handle all that forage while you're trying to put it up, that can be a huge deal. And then you've got the one you have no control over, which is weather losses. This all boils down to, I don't care how good you are, you're going to lose somewhere between 20 and 40% of the total nutrients that were there when you started. So on to the first thing, if we're going to actually make hay. So when you go swath it or cut it, that plant's going to be at pretty close to 75% moisture. So I can use an upcoming event next Monday. I believe everybody's going to be able to identify as Valentine's Day. So the ladies in the room can hang with me on this one. And if some old boy with a mullet goes and gets you a bouquet of flowers for Valentine's Day because he thinks you're kind of cute, would like to take you to dinner. What's the first thing you do with those flowers? You take them home and you put them in a vase, right? So those flowers are going to stay pretty for a given period of time. You know, you probably get a week with those flowers before they start looking a little bit puny. But if you do not put them in water, that you got a day with them, maybe. Here's the deal, is that a plant, unlike an animal, a plant doesn't have a brain and a heart, all those things, and nerves that designate whether it's alive or not. As long as a plant has energy and water, it's going to continue to do its thing. Now, it's certainly going to be limited by how much nutrient it's getting, whether it can continue growing or not. And the answer to that's probably no, because it no longer have roots. You removed it from the roots. The thing about it is that plant's going to continue its normal function, or as close to it as it can, as long as it's got water. And that magic number is about 40%. Once we get below 40% moisture in that plant matter, then the cells in that plant quit doing their normal stuff. They just quit trying at that point. Here's the problem. In between 75 and 40%, those cells are continuing to burn energy that it had previously stored from the photosynthesis process. That's energy you can't get back and you can't recover. So how fast we can get from 75 down to 40, that is the big primary question we need to deal with. So some of our equipment, we can help ourselves out a little bit, namely on the swathers. I've got this deal called the conditioner. Really all that is two giant rubber rolls that are pushed together as hard as they can be, and you run everything through there. So I'm trying to crimp those stems, and really what I'm doing is creating an exit for water. And this, again, all comes back to how fast can I get the water knocked out of that plant so those cells quit doing their normal thing and burning up the energy that I just soon feed the livestock. So the next little bugaboo we run into, and almost flying directly in the face of what I just said, is leaf shatter. So leaf shatter happens, you can all imagine this, and you've all seen this. You go somehow or another mow a plant, and out at the end of the leaves is what starts drying first, and the stuff that's laying on top dries first. And it might dry pretty quickly, in fact. We're still going to have to come in and mechanically turn that windrow over if we're talking about making hay. We got to turn that over so everything can keep getting air around it, and we continue that drying process as fast as we can. The problem is some of those leaves, and also here's what makes it an even worse problem is yesterday I talked about all of the best nutrition is on the farthest away, fastest growing parts of that plant. That's probably what's going to dry out the fastest. In fact, it may get so dry out there that it actually shatters when you touch it, and it just falls on the field then. I mean, the soil scientist in me says, well, that's a good deal. You know, that's a bunch of nutrients back in the field. Agreed. However, the larger point is I was trying to get that nutrient into a bale of feed to something. Yeah, so a lot of times you see hay growers, they go out and they try to rake hay or turn those windrows over early in the morning. And what they're trying to do is use any of the dew that came in overnight. It will kind of give those leaves a little bit of a rubbery consistency to them, and hopefully you don't shatter them and knock them off when you go to rake it. There are certainly types of rakes that are harder on hay than others. That's better left to an ag production class. Just needed to make mention of it. Okay, another one that we can get in pretty big trouble with is just weather damage. And by this, I mostly mean if if it took us too stinking long to dry that hay out, um, you get way more leaf shatter. Because again, those leaves are going to be drying, but the stems aren't going to be doing anything. So we're kind of getting the worst of both worlds right there. Given the right circumstances, if you can't get the moisture out fast enough, it's going to start molding. That mold is alive. It's digesting stuff. That mold is actually a fungus that's a parasite on plants, and it's pulling all the energy and the good nutrients out of a plant for mold to grow. And again, that's unrecoverable. You can't get it back. Another one is bleaching. Basically, that boils down to too much UV light exposure. UV light's hard on things. It just keeps pounding on it and pretty soon starts breaking it down. And then leaching basically boils down to if you got rain out there, it's literally going to just wash some of the soluble nutrients right out of the plant back into the soil surface. Again, no good if our purposes are putting up hay. Okay. So, yeah, mechanical losses. What is lost due to the action of actually putting up hay? So, leaf shatter, again, big deal. When we're putting it in bales, if we're using small bales or the little 2 or 3 string bales that you can actually move by hand, we're going to suffer more nutrient loss that way. And it's just because the equipment touches every little piece of it and you get more leaf shatter. You start using the big balers or round balers, you can gather up more nutrients, but there's some other things that you lose there. Like those big bales, you have to get it even drier because we're using more force to pack those bales together. The little bales or the round bales are kind of their own thing, and you understand what I'm talking about if you've ever fed one. So yeah, again, use the conditioners on your swathers. So heat damage during haymaking, you're not going to see that until you're up around 20% moisture. Hopefully you've just got it dried down further than that. You shouldn't see any mold if you're under 20%. You're still not dry enough at 20%, but that's just another mile marker that you need to pay attention to. That mold itself, or that fungus that's eating parts of the plants, isn't necessarily going after the protein in the plant. That's not its target anyways. But again, with that heat byproduct, if you do heat it up too much, you might actually cook those proteins. It's exactly the same thing happening as when you fry an egg or cook a steak. It changes the color. That denatured that protein in there. And a lot of times the proteins wind up not being as good as they were before, or certainly not as digestible. Another one here that has just become more and more of a dead certain conversation. But if you were buying hay or putting hay up, it used to be a discussion about whether you paid the $5 a ton to hire ITC tarping services or 1-800-TARP-IT, whoever, to come in and tarp a stack of hay. The thing about it is you're going to lose an additional 35% of the nutrients if you just do nothing. At least if you put it in a hay shed or tarp it, you're going to limit your losses to another 5 or 10%. With alfalfa hay, even the kind of average to crappy stuff costing $250 a ton today, at $8 or $9 a ton to tarp it, it's just a no-brainer whether you tarp it or not. You do it. Really, the only valid discussion right now is whether you spend a bunch of money one year and put up hay sheds, or you just continue with the annual charges of tarping. You're going to find that it's kind of 6 of one, half a dozen of the other. But I do know the answer is one or the other of them. It's not do nothing. So, losses due to weather here. This one boils down to a pretty short conversation. If it rains on that windrow hay after you've mowed it and you get that moisture content back up to 40%, regular cell respiration is going to fire off again. So rain on hay is no good. On top of that, we're washing nutrients out of the plant. On top of that, we're going to have to rake it at least once or twice more. It just starts adding up and adding up. And then again, we're lengthening the amount of time that windrow is laying out in the field before we get it put in bale. And we're going to suffer a whole bunch of UV losses there. So it just isn't any good if you start raining on hay. That's kind of what you need to know there. Okay, this is getting dangerously close to that one lecture I asked you folks to look at early. When it goes to assessing the value of hay, I want to speak to the people who are actually like feeding a set of cows through the winter or something like that. Here's my first comment for that. It's probably going to be either your second or third biggest line item in your budget for your entire year is how much you spend on hay. So what I'm getting at is if you spent that much money, why would you not know what's going on under the hood? Here's the analogy. If anybody went and bought a pickup, how many of you call it a day when you just say, well, that looks like a pickup, that'll work? Or how many of you actually lift the hood and find out, okay, has this got a Power Stroke motor in it, or has it got a Cummins motor in it, or has it got a Duramax in it? And you start asking some of these other questions, and you know exactly what you're dealing with there. Everybody makes their choice about what pickup they're going to drive, and some people buy brand new ones and show them off, and other people are driving old junkers. I'm not telling you what type of hay to buy. I'm just saying know what your hay is. In order to do that, we got to test it. There are a lot of things that we can tell by looking at it, but there's some things that we just got to send a test off. So when you're assessing hay, the first thing to do is you go look at it. And you can get a pretty good judge on what the maturity of the plants are that's in it. If we're looking at alfalfa, if you see a bunch of purple flowers in there, you know that hay's pretty rank. Grass, if you see these big seed heads that seeds are actually falling out of it when you kind of handle it a little bit, it was pretty mature, and we already know we're not looking at something that's all that great. I'm also going to tell you the biggest test you yourself can run is smell it. Your nose is going to tell you more about the quality of hay than anything. Good hay is going to have a fairly pleasant aroma. It's not going to be musty in any way. We can smell mold pretty well. You'll be able to smell mold. It has a real dirt aroma to it. Mostly it's just good hay is going to smell like your yard after you just mowed it. It will have a very pleasant, attractive smell to it. Some of the other things you can do is you can start looking at the leaf content, and I don't mean leaves of hay as a baler puts it together. I mean how much of the leaf of that plant is still there versus the stem. Of course, we want a high leaf to stem ratio. We'd love nothing more than to have way more plant leaf in there than we would stem. Stems don't have all that much nutrition in them. You're also going to be running into a palatability problem with stems. So that's all cool. You can learn some things about it. You love the nice, pretty green color. That does not tell you the entire story, though, so be a little bit careful of that. The next thing is you need to send it off for approximate analysis test. This is approximate analysis test. That's kind of the standard feed test. And what we're testing for, and believe you me, we're going to crack into this. It tells you how much moisture is there, throws it through the Kildall process, and we're just figuring out crude protein there. We're going to figure out how much of that is fiber. We're going to find out how much of it is ether extract or fat. And then they call it ash. Ash just refers to how much mineral is there. When we figure all of those things out, we can get a very good estimate of what the nitrogen-free extract is. The NFE, long story short, is telling you how much of that is like the good freebie type energy there. How much of this is easy. It does make sure you understand when we say nitrogen-free extract, that pulls the protein out of it too. So really that's just a test for how much energy is there. We don't have a test for NFE. We can just figure all the other stuff out and subtract it out, and what's left is the NFE. When we're talking about hay, we need to go a step further than just a approximate analysis test. So in this test for that NFE, we pulled the fiber out. But if we're talking about ruminant animals, they can get quite a bit of goodie out of that fiber. So really what we got to do is figure out what's going on with that fiber. That gives us our next test. So these two values that we're going to come up with are a big deal when we talk about nutritive value of forages. So the first one we're going to figure out is the NDF. To make this really simple right now, NDF is neutral detergent fiber. That's basically a test for how much fiber is there in total, all of it. The information we can get out of that, there's one thing that's really cool that we can get out of that. We can use that to get a pretty good guess on how much of this particular hay can we get a critter to eat in a day. And remember, we're all, at least in feeds, we're always driving for maximum intake. If we can get them to eat the most of something, we're going to get more performance out of them. So that NDF is telling us how much of that is fiber, and we can use that information to get a pretty doggone good guess on how much we can get this critter to eat. The next test is we're going to figure out how much of that neutral detergent fiber is acid detergent fiber. That acid detergent fiber is a pretty tough nut to crack, and a ruminant animal is not going to mine a whole bunch of goodie out of the ADF. So the ADF gives us a really good estimate on how digestible is it. So we use the NDF to figure out how much you're going to eat, and then we use the ADF to figure out how much of it's any good. So, all right, that's the end of it for today. I got through it in 28 minutes, so good for me, and I will see you folks Monday. Thank you.